In this lecture, we are going to prove an important relation, or it is said that an important identity relating to the difference operator. Okay, mainly the forward difference operator and the shift operator. And the relation is ux minus 1 by 8 into delta square ux minus 1 plus 1 into 3 by 8 into 16 delta to the power 4 ux minus 1 to so on. We have to prove that this is equal to ux plus half minus half into delta ux plus half plus 1 by 4 into delta square ux plus half minus so on. And we have to prove by the method of separation of symbol. Okay. Now we start from the left hand side of the expression, and we first already write the left hand side of this relation, and the left hand side is this. Here we use two important relations. The first is shift operator is equivalent to 1 plus delta. We already proved this relation in previous classes, and also we use here two important series. One of them is 1 plus x to the power minus n. This is equal to 1 minus nx plus n into n plus 1 by factorial 2 into x square minus n into n plus 1 into n plus 2 by factorial 3 into x cube to so on. This is the important series we use here. Okay, we first write the left hand side. This is equal to ux minus 1 by 8 into delta square into, we write this as e to the power minus 1 into ux. This is the definition of shift operator. We know that ux e to the power minus ux, this is equal to ux minus 1. Okay. Similarly, we write 1 into 3 by 8 into 16 delta to the power 4, and this is e to the power minus 2 ux. And the third term is 1, 3, 5 by 8, 16, 24 delta to the power 6 e to the power minus 3 into ux, and so on. Now taking common ux from the right, we get this is I minus 1 by 8 into delta square E inverse. Okay, and then we get 1 into 3 by 8 into 16 into delta to the power 4 e to the power minus 2 minus 1, 3, 5 by 8 into 16 into 24 into delta to the power 6 e to the power minus 3 and so on into ux. Now if we arrange this series as it is 1 or I minus, this is given by half into del square into e to the power minus 1 by 4. Okay, and we write this series is half into half plus 1 by factorial 2 into del square e to the power minus 1 by 4 whole square, and this term is half into half plus 1 into half plus 2 by, this is factorial 3 into del square e to the power minus 1 by 4 whole cube, and so on. Okay, and this is into ux. And clearly by writing this type of form, we may write this series as like this. So we get 1 plus delta square e to the power minus 1 by 4, this is whole to the power minus half into ux, right? And we get from here, this is e to the power half into e plus delta square by 4 to the power minus half into ux. Now taking common 1 by 4 from this bracket, we write here this is 2 into e to the power half, because this is minus whole to the power minus half, so we write outside this is 2 because 4 to the power minus half, this is 2, and in the bracket this is 4 into e plus delta square to the power minus half into ux. And now we put the value of e, shift operator. We already write here, this is the relation between shift operator and delta operator, and this is given by 2 into e to the power half into 4 plus 4e, 4 plus 4 delta plus delta square to the power minus half into ux. We get this relation by putting the value of e, this is equal to I plus delta, and we can write 4, otherwise 4i. Okay, and this is given by 2 into e to the power half into, this is 2 plus delta whole square to the power minus half into ux, and this is given by 2 into e to the power half 2 plus delta to the power minus 1, because 2 into minus half, this is minus 1 into ux. Now we take common from this relation 2, and we write outside here 1 by 2 because 2 to the power minus 1. So 2 and 1 by 2 cancel out, that is e to the power half into 1 plus delta by 2 whole to the power minus 1 into ux. Now we use the formula of 1 plus x whole to the power minus 1. 1 plus x whole to the power minus 1 means 1 minus x plus x square minus x cube plus and so on to infinity. This is an infinite series, and we write using this series e to the power half into 1 minus delta by 2 plus delta square by 2 square, this is 4 minus delta to the power 3 by 8 plus to so on to infinity into ux. Now using the commutative property of delta and e, that is e delta, we may write this is equal to e delta, this is equal to delta e, and using this property here we write this relation as e to the power half into ux minus delta by 2 e to the power half into ux plus delta square by 4 e to the power half into ux minus delta q by 8 e to the power half into ux and so on to infinity. And this result gives, because e with a shift operator, so e to the power half into ux, this is given by ux minus half, and the second term is minus delta by 2 into ux minus half. Third term is delta square by 4 into ux minus half and so on. Okay, and this relation is nothing but this is the right side of our given relation. Sorry, this is not u minus half, this is u plus half, because this is e to the power half, this is not e to the power minus half. So all the u are u plus x after using the shift operator e to the power half. Okay, so this is RHS, and this complete our given relation. Right, thank you for watching.